Hey, Dr. Mills, I'm Wes Newsom. I'm with LED Imaging. I'm the product line manager for our digital imaging products, from our intraoral cameras, intraoral sensors, to our pan cephs and 3D units.
Tell me a little bit about your background.
I actually came from a competitor of ours. I worked for them for about 11 years. I started off in the tech support department and then evolved into the product line management group. I was actually a field engineer while I was in the tech support department, then moved into product line management, focusing on intraoral cameras, intraoral sensors, pans and cephs, and then we evolved our product line to include 3D, wireless intraoral sensors, high-resolution automatic focus cameras, more in-depth software. So taking that skill set and now transferring that over to a smaller company so that we're a little more nimble, we can work with other manufacturers and really offer the best products that we can.
Awesome. And today you're going to end up talking to us about the RayScan, which is one of your new cone beams. Right?
Exactly. This is our the top of the line pan ceph CBCT unit in the dental market. It's a optimal field of view of 9 by 9 centimeters. It's actually manufactured by Samsung. Ray Company is a subsidiary of Samsung, so it's utilizing a lot of their technology, making sure that we have optimal dose, optimal field of view, optimal image quality with a very smooth, easy to use workflow.
Tell me what makes this product or with this cone beam unique. There's a lot of other cone beams out on the market. You know, tell me what's unique about it.
Well, we're not first, clearly. CBCT and dentistry has been out for 10, 20 years or so. What we've done is refined and improved on what's already out there. So like I said, we have a optimal field of view of 9 by 9. So we're getting both jaws, all the way third molars on both sides. We have a optimal cooling technology inside the sensor and tube head itself so that the unit doesn't overheat, so we get optimal image quality every time. We have a easy to use patient-friendly positioning, so the patient can step in, the operator can position them very easily. We have a ceph that hangs off the left side for orthodontics. We also have an optional flat panel one-shot ceph option coming in the fall of this year. And we also have very high resolution pans. Everyone likes CBCT for the 3D images, but we also have a dedicated pan sensor, which is usually the bread and butter of an extraoral machine, and we have very high resolution panoramic images.
Talk to me about a little bit about the resolution of the 3D image, because you know, from an implantologist point of view, that's going to be the real bread and butter distinction between, you know, some of the different machines. How does the actual resolution of this machine compare to some of the other machines?
Well, resolution is not just voxel size. There's a number of other factors as far as noise in the image, how much radiation is actually used to get the image, and really what you can do with the image once you get it. So we do have a very high resolution image at 140 micron in our endodontic mode, but we also have a standard mode, an implant mode, an implant guide mode that can do 210 or 280 micron as well. So you have the choice of a higher volume or higher file size with a higher resolution, with a little bit slower reconstruction, or you can have a very high reconstruction, smaller file size, so you don't have to back up quite as much, with a standard resolution, so you can do most of what you need. So if you're doing implants, looking for anomalies in the anatomy, you can use your standard resolution. But if you do need a higher resolution, really need to see a root canal for an endodontic case, we do have a 140 micron option.
What about your metal filters?
We've got metal artifact reduction inside of the software, so for any restorations that are inside of the patient's anatomy, you don't have nearly as much scatter. You can see a lot more of what you need to see in the image without a lot of scatter or streaking throughout the image.
Is that automatic, or does it take additional technical skills on the view of the, or intellectual skills on from the part of the clinician?
It's meant to be as simple as possible. It can be toggled on or off. If for some reason you feel like there's some anatomy that you're not seeing because of the metal artifact reduction, you can turn it off, or you can turn it on and get a cleaner image and see the anatomy around it a little bit more cleanly.
Okay, that's awesome. I want to look at the machine, so why don't you end up showing us the machine and just giving us an overview of how the machine looks like first, and then you can run through the software, and then we'll go ahead and scan a patient and see how the images actually look.
Sounds great. Let's do it.
Okay, awesome.